Welcome back to the Geog 300 Geographical Data Analysis video series for WVU. We are continuing with the ideas of inference where one of our variables is categorical and the other is continuous, or nominal and in the interval or ratio parts, depending on how you want to classify or characterize your data. We're now looking in more depth if we have two categories. As I said, that is when we have the t-test. We saw the t-test earlier, so you already have a general sense of how it will work. There is a bit more to it. There are actually more kinds of t-tests than I showed before, and we'll see each of those basically now. 3 different kinds. And the first one doesn't even actually use 2 samples. It's called, in fact, the one sample t-test. And it can be easily confused with the z-test because each of them only has one distribution, one set of data. But whereas the z-test is looking at a single data point, does it fit in with the rest of the distribution? This is still making an inference about the mean of a particular distribution of our data. So it's still focused on the mean as opposed to a single value. That's the distinction here, and the thing to look at in the question that you're trying to answer as far as trying to identify what the appropriate method is. So I'll put up that first one here, the one sample t-test. So it's comparing, I just have it generically here for the time being, comparing a group or the mean of a group of values, so the mean of that distribution, and saying is that close to, or is it higher or lower than some other value. This can be useful in turn, and the null hypothesis here is that they are the same, that the mean does match that external value. The alternative, by extension, is that they don't. So, an example would be if I want to look at the mean unemployment rate for West Virginia counties. And I may want to ask, okay, is this close to, or is it similar to the overall national unemployment rate? So I'm taking some other value, the overall national unemployment rate, and comparing the average unemployment rate of West Virginia counties against that other external value to say, is the mean of the county unemployment rates in West Virginia, does it match that national one? And if it's higher, then we might say we need to have some economic action from the state government, from the federal government, to address an employment crisis here within the Mountain State. So there's how we can then go all the way to using the answer to that one sample t-test. Next, we have a standard 2 sample t-test, and that's what we saw before. So to take again that example, mask mandates. Are the COVID rates higher? Are they the same? Are they lower? Within the framework of so are COVID rates the same or different where there are versus are not mask mandates? That would be the two sample t-test. That's probably the one that would be most commonly applied. We can also say, to take that unemployment example, okay, West Virginia counties, is the average unemployment rate for West Virginia counties the same or equivalent to the average unemployment rate for Kentucky counties? So now I have two groups, West Virginia, Kentucky, and I am comparing them. That would be another two sample t-test. The third kind of t-test So we have something called a paired t-test. Oh, in a paired t-test, it is really superficially similar to the two sample. You're going to be working with two sets of numbers. But then, can you match them up? Most of the time, this comes in the form of a before and after. So, in the COVID example, we might say, okay, I have a series of places that implemented a mask mandate. I have the COVID rates from before that happened and the COVID rates after that happened. I can now pair them up. It's the same place, but doing a before and after check to say, did the mask mandate reduce the COVID infection rate from where it was prior to the implementation of that mandate? To carry with the unemployment example, we could say, I identified from the one sample t-test that yes, West Virginia has a higher unemployment rate, we need to enact some kind of policy. I go and I carry that out. Now I want to see, is that policy working? And I can compare the unemployment rate, again, from prior to that policy's implementation to the unemployment rate after that policy's implementation. And I can say, is there a difference? There is one other important question within our t-test setup. So we have the three kinds here: one sample, two sample, and the paired t-test. In all three, we can have one other question that leads to, in fact, 6 varieties of t-test, because we can break each of these down into 2 different approaches, the same, and they're equivalent. And that is a thing called a one-tail or a two-tail t-test. And this then gets to how we work with that distribution. So the distribution of the t-test is, or the t-statistic, is based upon the different means, the variances or the standard deviations, comparing them, and we then say, here's what it would be under the null hypothesis. And it's going to be something similar to a normal distribution, except the tails are a bit thicker. But I then go and I say, I want to compare and say, okay, I find a t-value 2.09. If I just go higher than that, I've only colored in one tail. And it gets back to the hypothesis, the null hypothesis that we're working with. It so happens that the way I had typically been phrasing them, at least on the board, and saying no difference, that's actually getting to a two-tail test. Here, the one-tail test, I only have the area greater hypothesized and filled in. That means I am suspecting there is a direction to that relationship. If t happened to be -3, it would not show up here as noteworthy, even though it is actually further away from the expected value of 0 in that distribution than the 2.09 that I have here. In a one-tail test, by specifying that direction, it's actually saying, say to revisit the two-tail examples that I had, instead of just saying the COVID rate in places with the mask mandate is the same as COVID rates in areas without mask mandates, to specify that it's just the same, then okay, we have our direction. Or we do not have a direction. If I say the COVID rates are lower in areas with a mask mandate, now I am specifying a direction. I'm hypothesizing this. Or I could say they are, since I put a positive number, we can say they are higher in areas without a mandate. Now the null hypothesis becomes the rates are not higher where there is no mandate. That's saying they could be the same. That's actually along the possibility that they could be lower. Just saying they're higher. Okay, just do that. We now are specifying that direction. We only want the one tail. If I just said they're the same, do I include this part? If I am just saying they're equivalent, there's no difference, then I am allowing the possibility it could be higher or it could be lower. So when I am looking at the paired t-test that I gave with, or not the paired, the other two sample t-tests, West Virginia versus Kentucky, I don't know off the top of my head, I don't have any particular reason to suspect one's higher than the other. So now, with no direction specified, I would say if t equals 0.209 or greater, or minus 0.209 or less. If it's in either of these, I would say, yep, there's a difference. From that simple conclusion, I'm not saying that's higher, it's lower. Strictly speaking, I would just be saying, yes, there's a difference. I can then compare the means and say it's higher or it's lower and fill in that information, but the statistic is only checking, are they the same? And to say, does the data support that null hypothesis that they are the same? It so happens that, at least with a t-test, because the t-distribution is symmetrical, values above the mean are just as likely as values below the mean of that distribution. The p-value for the two-tailed is going to be double the p-value for the one-tailed. And as we will see when I do a demo in class, the software, Excel, actually provides both for us. Within, again, to just provide examples with the paired t-test, we had the idea that the mask mandate would lower the COVID rate from before to after. By specifying that implementing a mask mandate should lower the infection rate, that leads to one-tailed. Lower tells me that direction. Likewise, when I say implementing this policy should reduce the unemployment rate, reducing the unemployment rate is again a direction. We might, as an example where we could have a paired t-test as one-tailed, or sorry, that is two-tailed, with, again, I'll stick with the unemployment. Let's say, okay, we just had a new state legislature take office. They're in session right now. And I could say, collectively, are the policies for this state, for this legislative session, going to increase or decrease the unemployment rate? I don't know what they'll propose. I don't know if it would help or if it would hurt. I could then just say, look at the unemployment rate 6 months from now, after the session is concluded, against the unemployment rate from 6 months ago, prior to even their election at that point, to say, if I compare those, did the policies of this session have an effect on unemployment? That effect could be positive, that effect could be negative, I'm not specifying, therefore, I want a two-tailed test to see if this particular legislative session is affecting the unemployment rate. So there we have more summary of t-tests. Looking at 3 different kinds. The one sample comparing the mean of a group of values, the mean of some group, against an external pre-specified value. Second, a 2-sample t-test, where we're breaking our data down into 2 groups and comparing the mean of each of those groups. And the third, a paired t-test, where we can have some kind of matching, like before and after, of the same place or the same observation, the same unit, and be able to truly match them up and compare the difference between each pair. Within each of those 3 types of t-test, 1 sample, 2 sample, paired, we can also say, do we want a one-tail evaluation where I am specifying I expect one group to be higher or lower than the other, and I know which one of those two I want, versus a two-tailed where I'm just looking to see, are the two different? And I don't have any reason to suspect higher or lower for either particular group. I just want to know if they're the same or if they are different. That would be the two-tailed. So in the next video, we'll look at what we do if there are 3 or more categories instead of 2. And as always, please feel free to reach out if you have questions. Thank you for watching.